You know how a pressure cooker works, right? You see a water inside, crank up the heat, and it builds this intense pressure that cooks food super fast. Well, just imagine that same idea, but scaled up, way up, to power something like a locomotive or even an entire factory. That, right there, is the basic genius of a steam boiler. So yeah, let's dive into this simple but totally world-changing piece of tech.
So, at its absolute core, a steam boiler has just one job: turn a liquid into a vapor. But we're not just talking about boiling a kettle for tea here. Modern boilers are engineered to create absolutely massive quantities of steam and at incredibly high pressures and temperatures. It's really all about harnessing the hidden power of water itself.
Okay, so how does it actually do it? Well, you can think of it as two main parts that have to work together perfectly. First, you've got to have a furnace. That's where you burn your fuel to generate some serious heat. And second, you need a totally separate enclosed space where all that steam you're making can collect. It's a beautifully simple idea, really. Make a fire and use that fire to boil water.
This image here, it really lays out the whole energy journey. It all kicks off with the chemical energy that's locked inside the fuel. Then, through combustion, that's the fire part, it's converted into heat. The boiler's big job is to get that heat over to the water, creating pressurized steam. And that steam is a really powerful form of kinetic energy. So let's start right at the beginning of that chain, with the fire.
Everything begins with the engine of the entire system, the combustion process. See, to make all that steam, you first need a really stable and incredibly hot source of heat. So, the question is, how do you manage and optimize a fire that intense inside a giant metal box?
Well, it's actually a very precise three-step dance. First, you've got these things called mechanical stokers, which are kind of like automatic feeders. They just keep pushing the fuel into the furnace at a nice, steady rate. Second, a very specific amount of air gets pumped in, and this part is absolutely critical. Because if you don't have enough oxygen, you get incomplete combustion, which means you're wasting fuel and not getting enough heat. The whole goal is maximum efficiency.
And here's the key takeaway from all that. The fire itself isn't really the final product. Nope. The fire's only job is to produce the real workhorse of this system, a massive, massive volume of incredibly hot gases. These gases, they're the ones that are going to carry the energy from the furnace over to the water.
Okay, so we've done it. We've made our super hot gases. Check. Now comes the next big challenge. How do you transfer all of that thermal energy into the water as efficiently as you possibly can? How does that heat actually get from point A to point B? This is where the engineering gets really, really clever. The hot gases aren't just, dumped into a big tank of water. No way. Instead, they're carefully funneled so they have to flow all around this huge network, or banks, of tubes that are filled with water. This whole design is meant to maximize the surface area, making sure as much heat as possible touches those pipes.
And you can probably guess the results. As those scorching hot gases wrap around the tubes, the metal heats up almost instantly, and the water that's flowing inside just soaks up a huge amount of that heat. It's this super fast absorption that flashes the water into high-pressure steam.
And here's another key engineering trick. They want the water moving through these tubes as fast as humanly possible. Why? Well, because water that's moving faster creates turbulence, and that turbulence actually helps it absorb heat even more efficiently. Plus, it prevents any one spot on the tubes from getting dangerously hot. It's all about making that heat transfer happen lightning fast.
Now, trying to contain this much heat and this much pressure, that's a huge engineering challenge. A boiler isn't just about making steam. It's about making steam safely and without wasting a ton of energy. And this last part is all about that smart, protective design.
So the designers are really juggling two main goals, and sometimes they're even competing with each other. On the one hand, you've got efficiency. So the combustion chamber is lined with fire bricks, which is basically insulation to keep all that precious heat from escaping. But on the other hand, you have safety and durability. The structure itself has to handle insane pressures, and that's where things like water tube balls and safety valves come into play.
Okay, check out this brilliant solution to a really big problem. The intense heat from the furnace can actually damage the solid walls of the boiler. So what did the engineers do? They decided to line the furnace walls with, you guessed it, more tubes full of water. This design actually uses the water to absorb all that stray heat. It cools the walls, and it makes even more steam. It's a win-win, a genius self-protecting system.
But what happens if the pressure just keeps building up?
what if something goes wrong? There has to be one last line of defense to prevent a total disaster. And that brings us to what is probably the most critical safety feature in the whole thing.
It's called the stop valve, and it's basically just an emergency release. It's calibrated to pop open automatically if the pressure inside the boiler gets higher than its safe operating limit. It literally lets off steam to prevent the entire system from, exploding. It's the simple, non-negotiable feature that makes this incredibly powerful technology safe to use.
So, when you put all these pieces together, you realize the steam boiler isn't just some big, dumb brute force machine. It's actually a pretty elegant system. It intelligently manages a controlled chemical reaction, the fire, and then expertly transfers that energy into a usable force, all while protecting itself with some really clever and tough design.
I mean, it's no exaggeration to say the steam boiler powered the Industrial Revolution. Everything from trains to power plants, but that fundamental idea, turning a liquid into a powerful vapor, it's all around us. So think about it for a second. Where else do you see that principle at work? Maybe in your kitchen, in the weather? It's a simple bit of genius that is, for sure, still shaping our world.